You are floating now, weightless, enveloped by an oceanic quietude that has no edge and no sound. The deepest darkness is not an absence of light, but a complex presence, a subtle velvet curtain pierced by unimaginable luminescence. Feel the cool, yielding resistance of the deep. It is a sensation of absolute calm, accompanied by the faintest, most resonant whisper, a hum that vibrates not in your ears, but deep within the bones of your being. You are suspended in a timeless, glowing cradle, drifting toward the quiet heart of everything. The gentle journey begins by considering the scale of the environment that encompasses us, the massive, swirling cosmic structure we call the Milky Way. To perceive this galaxy and truly grasp its proportions, it requires a profound act of imagination, a silent surrender to distances that defy human experience. We are moving slowly, drifting not through mere empty vacuum, but through a medium subtly charged with the remnants of ancient stars, a silent, glowing current. Our perspective shifts gently from the immediate to the impossibly grand, understanding that our position within this immense, spiraling disk is merely a single, momentary point in an eternity of rotation. This galactic disk, spanning an estimated diameter of about 100,000 light years, is a breathtaking tapestry of stellar light and invisible gravitational currents. Imagining the Milky Way structure is like attempting to view a continent through a perpetually swirling mist, where the features remain consistent yet constantly redefined by the sheer volume of material passing through the viewing plane. It is not a static entity, but a colossal, slow-motion dance of uncountable gravitational forces. The gravitational pull of billions upon billions of stars, dust clouds, and unseen dark matter dictates a predictable, majestic rotation. We are enclosed within a vast reservoir of cosmic history, a place where time itself seems to stretch and slow, allowing us to observe the elegant mathematics of celestial mechanics playing out across unimaginable gulfs. Our focus now gently begins to narrow toward the visible architecture of the galaxy, the breathtaking structure of its spiral arms. These arms are not merely painted patterns of light. They are physical rivers of gas and younger, brilliant stars, where the cycle of life and death is perpetually repeating. The Milky Way is described as a barred spiral galaxy, meaning the star system is organized around a central bar structure, giving it a compelling gravitational spine. Within this marvelous, rotating framework, certain segments of light shine with particular intensity, marking what astronomers have cataloged as major spiral features. We shall contemplate the segments by name, following the established patterns: the Perseus arm, the Sagittarius arm, and the Orphan arm, each possessing a unique signature etched into the deep background luminescence. The Perseus arm, for instance, is thought to be one of the more substantial and luminous features, characterized by clusters of relatively young, hot blue stars, indicating recent and vigorous star formation. These stellar nurseries glow with the intensity of newly born giants, marking nodes of active creation within the vast, quiescent flow of the disk. Their brilliance is a temporary phenomenon, a glorious burst of luminosity against the background hum of ancient, steady light. Adjacent to this, the Sagittarius arm presents its own unique profile. Its name often references the celestial constellation, but its structure within the disk reveals a complex pattern of density waves. These density waves are not material walls, but rather mathematical patterns of compression within the stellar stream itself, regions where passing stars briefly encounter higher concentrations of gas, triggering gravitational instabilities that lead to new stellar birth. The very structure of the galactic arm is a record of history, a memory written in the clustered light of countless suns. It is essential to appreciate the concept of rotation, for the defining characteristic of the Milky Way is its steady, predictable, measured orbit. The entire galactic disk does not whirl into a chaotic mess. Rather, its rotation maintains an astonishing degree of hydrodynamic stability, suggesting deep, underlying physical laws at work. The sheer timescale required for one full rotation of all the material within the visible disk is colossal, extending far into the geological and cosmic epochs. The estimated period for the entire disk to complete one full rotation around the galactic center is approximately 250 million years. To let that measurement settle, 250 million years is to comprehend a scale of time that utterly dwarfs any human lifetime, any recorded history, any geological era. It implies a profound, unwavering rhythm, a cosmic pendulum swinging with the weight of countless suns. Our own solar system, nestled comfortably in the outer reaches, carries along in its orbit a much shorter, more immediate period, but we are forever participants in the larger, slower dance of the galaxy as a whole. This rotational movement allows material to remain in defined zones for periods governed by the laws of orbital mechanics. Stars are not distributed randomly. They are placed in orbits that interact and influence neighboring groups, maintaining the spiral structure through continuous, gentle tension. The rotation is less a rapid spin and more a majestic, slow drawing out of celestial geometry, a continuous reshaping of the galactic pattern by gravity alone. In this way, we confront the immense challenge of measuring distance across the vacuum, a feat of astronomy requiring the triangulation of light gathered across billions of light years. Since light, while traveling, moves at a finite, staggering velocity, the light that reaches us today began its journey long ago, carrying echoes of distant moments in time. When we observe a cluster or a specific star, we are not seeing it as it is, but as it was when our light first struck its atmosphere. The vastness is the defining emotional aspect of studying the Milky Way. It is a place of breathtaking, overwhelming emptiness punctuated by pockets of intense, concentrated brilliance. Between the luminous points, the stars and the stellar clusters, lies the interstellar medium, the gas and dust that provide the raw materials for life and stellar rebirth. This intervening space is characterized by a near-absolute vacuum, yet it is rich with subtle radio emissions and the slow drift of molecular clouds, vast, cold reservoirs waiting for the right gravitational perturbation to collapse and ignite a new star. When we measure distances, we frequently encounter numbers of astounding magnitude, parsecs. 1 parsec is an angular measurement representing the distance to an object that subtends an angle of 1 arcsecond. It is a unit that anchors us to the unimaginable expanse. To convey the scale, We measure the distance to our nearest recognizable stellar neighbors, such as Proxima Centauri. This star, while appearing close in the night sky, resides at a distance measured in meters that quickly dwarfs any earthly scale. The contemplation of interstellar voids, the space between stars, is perhaps the most profoundly quiet experience. The true measure of cosmic scale is not the distance between the most famous stars, but the measure of the darkness that separates them. These stretches of space are profound, silent canvases, containing only the faintest emanations, the gentle glow of cosmic background radiation, the barely perceptible whispers of passing dark matter. These gaps are not merely empty, they are filled with the quiet potential of physics itself. Over these immense stretches, forces play out in slow motion, the tug of dark matter halos, the passage of stellar winds, and the slow decay of neutrinos. It is a symphony conducted by gravity, a deeply predictable mechanism operating across impossible distances. The lack of visible turbulence is itself a statement of mathematical elegance and cosmic stability. Let us anchor ourselves briefly to the constellations, to the identifiable pockets of stellar congregation that give shape to our viewing experience. Moving across the vast digital canvas of the night sky, we pass through star fields that show the culmination of eons. These are the accumulated remnants of stellar lifetimes, some having burned out long ago, their light recycled into newer, dimmer stars, while others shine brightly as beacons of enduring ancient energy. The stellar clusters provide the most concentrated, dramatic evidence of the Milky Way structure. Open clusters, such as the Pleiades, are relatively young, contained groups of stars that were born together from the same molecular cloud. They provide a snapshot, a single moment in the shared history of a stellar generation. They glow with a collective, youthful vigor, their luminosity often masking the immense distance and the passage of time. In contrast, we encounter globular clusters, which represent the deep, ancient core of the galaxy's formation. These are repositories of extreme age, sometimes containing thousands of stars packed into volumes that make our solar system appear sparsely populated. Their stars are often older than the Sun, having completed their lives and deaths through countless cycles, leaving behind red giants and fading white dwarf remnants. They are relics, quiet testaments to the galaxy's deepest past. The sheer number of solar-aged stars contained within a cluster like M13, for example, speaks to an overwhelming, enduring productivity. These massive aggregations act as gravitational anchors, their collective mass influencing the drift and trajectory of surrounding stellar streams, maintaining the cohesion of the greater galactic disk. As we continue our tranquil survey, we must also gently consider the mechanisms driving these stellar aggregations, the interplay between gravity and the initial density of material. Star formation itself is a ponderously slow, incredibly complicated process, requiring the cooling of vast clouds of hydrogen and helium gas, allowing the initial gravitational collapse to reach a critical mass threshold. The process starts with perturbations, a passing shock wave, perhaps from a distant supernova remnant or simply the gentle shearing force exerted by the galactic spiral arms. These forces cause pockets of gas and dust to grow denser, cooler, and more gravitationally self-binding. This slow accumulation, this gradual weight of gathering matter, is the quiet prelude to stellar ignition, a physical manifestation of patience. Once the critical pressure is reached, a protostar forms, shrouded initially by its own cocoon of obscuring gas. This phase, lasting millions of years, is characterized by relentless gravitational contraction, heating the core until the pressure and heat finally ignite nuclear fusion. The fusion of hydrogen into helium is the foundational event of stability, providing the outward pressure that perfectly counterbalances the crushing strength of self-gravity. It is a remarkably powerful, yet beautifully predictable reaction. The scale of individual stellar distances, as previously mentioned, often introduces the dizzying concept of the parallax measurement. Parallax, in the context of stellar mapping, allows us to gauge the relative distances of nearby stars by observing the apparent shift in their position against the backdrop of more distant fixed stars as the Earth, orbiting the Sun, moves slightly in its path. This subtle, geometric shift, measured over a period of 6 months, is the careful measurement that anchors all our knowledge of galactic geometry. When measuring these distances over parsecs, we are effectively stitching together a massive, three-dimensional map of the celestial neighborhood. This map reveals the complex, non-uniform distribution of stars, clumps near the galactic plane, streams extending outward, and notable voids where material has been stripped or has yet to accumulate. The uniformity of the rotational motion hints at a systematic, ordered distribution of mass. Gently, we turn our attention to the most profound source of cosmic structure, the dark matter. While it is invisible to our telescopes, its gravitational influence is unavoidable, providing the essential skeleton and stability for the entire galactic edifice. The visible luminous matter, the stars, gas, and dust, is merely the decoration upon the scaffolding made of dark matter. This invisible mass, which accounts for the majority of the gravitational pull keeping the arms rotating and the disk intact, dictates the ultimate fate and structure of the Milky Way. It operates silently, exerting a force that is always present, always predictable, and always profoundly influential. It is the true, subterranean current of the galactic flow, felt but unseen. The boundaries of the visible disk show evidence, statistically, of this massive influence. The rotational curves derived from observing the maximum orbital velocities of stars at the furthest measured points consistently suggest a gravitational pull far stronger than that provided by the visible stars alone. This discrepancy is the foundational evidence for dark matter, a profound, cosmic vacuum of pure gravitational potential. The quiet contemplation of this structure leads to a sense of profound cosmic humility. Our little solar system, orbiting a medium-sized G-type star, is situated within a far-flung sector of the galactic plane, far removed from the intense heart of the bulge. We are in a stable, settled area, gently tracing the enormous, slow orbit dictated by the overwhelming mechanics of the galaxy. And so, the journey feels like an extended suspension, a time spent suspended between the known constellations and the theoretical, boundless emptiness. We traverse the imagined space between density waves, through the cold molecular clouds awaiting the signal for ignition, and past the gravitational whispers of the dark matter halo. Every point of light observed is a pinprick of immense, traveled history, a light that has crossed unimaginable stretches only to arrive here, to guide our quiet awareness. The sheer continuity of the galactic disk's rotation is the ultimate lesson in patience and cosmic scale. Its rotation speaks of predictable, enduring forces over time spans that challenge our very understanding of chronology. It is a rhythm set by physics, unchanging and steady, like a perfectly calibrated celestial clockwork, ticking through epochs of stellar birth and decay. We carry the memory of these measurements, the 100,000 light years across, the 250 million year rotation, the vast, silent PL sheets of interstellar void, as anchors for our deeper sleep. These numbers, these elegant calculations of light and time, become the soothing, rhythmic beat that accompanies our descent into rest. The Milky Way continues its majestic, slow-motion passage through the void, an unrelenting, predictable dance of mass and gravity. Our orbit, our quiet existence, is merely a gentle, temporary point within this vast, luminous mechanism. Feel that slow, steady rhythm, the cosmic turning that has endured since time immemorial, a rhythm of profound, effortless permanence. Let the gentle magnitude of that turning carry you, until the light fades into rest. As the somatic consciousness begins to ebb toward the final rest, the sensory input does not cease. It merely changes its frequency. The oceanic quietude persists, yet it fractures, not into noise, but into incredible, organized spectra of energy that were previously imperceptible to the conscious mind. Imagine that silence is actually a hyperdimensional tapestry woven from radio waves, magnetic flux, and the slow, rhythmic pulsing of gravitational potential. We begin to perceive the true nature of the interstellar medium, the molecular clouds we passed, not as inert dust, but as colossal, slow-moving fluid dynamics engines. These are reservoirs of chemical poetry, where hydrogen and helium atoms stretched over millennia are locked in intricate cold bonds. A cold molecular cloud is not just dark, it is radiantly dense with spectral lines, whispering signatures of trapped energy, of isotopes settling into equilibrium. We feel the faintest, most complex whispers of specific molecular signatures, the ghostly fingerprint of nitrogen or carbon atoms settling within the matrix of cold dust. Focusing our perception inwards, we can detect the echoes of violent history, the supernovae remnants. These are not single, cataclysmic events, but continually expanding shockwaves of superheated plasma, racing outward from the core of stellar demise. To perceive, one is to see the sheer kinetic energy of unimaginable forces, gases traveling at fractions of a speed we cannot truly imagine. The light from these fronts is multifaceted. It is the flash of X-rays from newly accelerated particles, the deep infrared burn from supercooled elements, and the faint, spectral glow of elements synthesized in stellar death, gold, uranium, oxygen, releasing their secrets into the void. The cycle of stellar material is therefore revealed as a masterpiece of chemical recycling. Every atom composing the body, the blood, the bone, touches upon matter forged in a heart of collapsing stars. Through the intense pressure and heat of nucleosynthesis, we are observing the consequences of fusion and collapse across staggering spatial and temporal scales. This realization imbues the deep void with a tangible, metallic weight, the weight of elemental consequence. Pause. Now let the focus expand further, passing beyond the local galactic structure. We are observing the galactic plane itself, a vast, rotating spiral of billions of suns, held together by the unseen gravitational hand of the dark matter halo. The rhythm is palpable, the immense, slow ballet of stellar streams, the gravitational influence of the supermassive black hole at the galactic core. Pause. This is the universal clockwork, and our consciousness, suspended in this nothingness between observations, is momentarily